Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 1 Higher Tier from 2020. Question number 7 is on the topic of energy. Kangaroos are large animals that travel by jumping. Figure 8 shows a kangaroo. Each leg of a kangaroo has a tendon connected to a muscle. Each tendon can be modeled as a spring. So, when you're talking about a tendon, let's say it's in here. Use a different color. There you go. It's in there. Now, when a jumping kangaroo lands on the ground, the tendons stretch. So when it lands, it's going to stretch this way. Figure 9 shows a sketch graph of how the maximum tendon length during a jump changes with the speed of the kangaroo. So as the speed increases, the maximum tendon length is actually increasing as well. Now at its resting stage, it has this is your resting normal length when it's 0. Explain why a kangaroo can jump higher as the speed increases. Now as the speed increases, the maximum tendon length is increasing. That means it's extending more. If the extension increases, that means elastic potential energy will increase. Remember, elastic potential energy, EE, is equal to half KE squared. K is a spring constant. If you, let's say, even if K is 1, if you increase the extension by double it, then you are going to increase the elastic potential energy quadruple. Okay? So, explain why a kangaroo can jump higher. If it has more kinetic elastic potential energy, that means it can transfer most of it to gravitational potential energy. So the maximum tendon length extension increases as the speed increases. So the elastic potential energy increases, which is transferred to gravitational potential energy. A kangaroo has a maximum gravitational potential energy during one jump of 770 joules. When the kangaroo lands on the ground, 14% of the maximum gravitational potential energy is transferred to elastic potential energy. So 14% out of this 770 joules is transferred to elastic potential energy. The tendon has an unstretched length of 35 centimeters. When the kangaroo lands on the ground, the tendon stretches to a length of 42 centimeters. Calculate the spring constant K of the tendon. So again, the equation that we need to use is elastic potential energy equals half the spring constant multiplied by the extension squared. Now we can find the extension using these two values, 35 centimeters and 42 centimeters. So extension is equal to 42 minus 35, that's 7 centimeters. Let's change it to meters. That will be 0.07 meters. The next thing that I would need to find the spring constant over here is the energy, the elastic potential energy, which is 14% of this gravitational potential energy. So the energy is 770 multiplied by 0.14. That gives me 107.8 joules. Now I can use both of these values in order to find the spring constant. So let me rewrite the equation. E for elastic potential energy is equal to 0.5 instead of the half, multiplied by K multiplied by the extension squared. So 107.8 equals 0.5 times K times 0.7 squared. Rearranging the equation, K equals 107.8 divided by 0.5 times 0.7 squared. That would give me a spring constant of 44,000 Newton per meter. That's 44,000. That brings us to the end of this question paper. Thanks for watching, and I will see you in the next video.